Welcome to episode 82 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data in AI with you.
And I'm Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Driving AI innovation on the road, that's what today's episode is all about. We're diving into a real-world case study that's reshaped mobility, Tesla.
Tesla has become synonymous with electric vehicles, but even more fascinating is how they've harnessed AI to push autonomous driving forward. It's revolutionizing how we think about cars and transportation.
To start, let's unpack what autonomous driving really means from a data and AI perspective. At its core, autonomous driving is the capability of a vehicle to sense its environment and navigate without human input.
Right, and that sensing relies heavily on AI technologies like computer vision, sensor fusion, and deep learning, feeding from tons of data generated by cameras, radars, and ultrasonic sensors around the car.
Exactly. Tesla's approach is largely built on neural networks trained on petabytes of driving data. They use this data to teach the system to recognize objects, predict movements, and make decisions much like a human driver would.
And what's really interesting is Tesla's decision to rely predominantly on cameras combined with radar, rather than the more expensive LiDAR systems that many other companies use. That's a very data-driven strategy because it emphasizes software solutions over hardware.
Historically, LiDAR provides detailed 3D maps of the environment, making object detection easier, but it's costly and complex. Tesla bet on vision-based AI, mimicking how humans drive, primarily with their eyes.
From a consulting standpoint, that's a brilliant move because it lowers costs and allows faster scaling. Tesla cars on the road continuously generate data, which then feeds into their centralized AI training pipeline, improving the system with every mile driven.
This creates a feedback loop known in machine learning as continuous learning or online learning. As Tesla's fleet gathers new scenarios, the AI learns and updates more quickly than traditional static models.
I've seen companies in other industries try to build similar feedback loops, say in retail or healthcare, but few achieve Tesla's scale and speed. It's a prime example of how data strategy and AI model management go hand in hand.
Diving deeper into the technical side, Tesla uses a combination of supervised learning and reinforcement learning. Supervised learning helps the system identify lanes, signs, and other cars based on labeled data, while reinforcement learning can help it refine decision-making in complex, dynamic environments.
And while a lot of the heavy lifting happens behind the scenes, Tesla's user experience reflects these AI capabilities. Features like autopilot and full self-driving are updates pushed to the car over the air. Customers get smarter vehicles without needing new hardware.
This software-first approach is transformative. Traditionally, cars are hardware products with fixed features. Tesla treats their vehicles more like smartphones that improve through software updates.
It's an important lesson for businesses. Investing in scalable data infrastructure and flexible AI models can turn your product into a living system that evolves.
One challenge Tesla faces is edge cases, rare or unexpected conditions that the AI hasn't encountered before. These are the toughest for autonomous systems to handle because data on such scenarios is limited.
In practice, Tesla mitigates this by using their vast fleet as distributed sensors all over the world. If one car encounters a rare event, that data can be quickly shared and incorporated into the AI training set, effectively crowdsourcing unexpected scenario coverage.
This is reminiscent of what we call federated learning. Although Tesla has a more centralized architecture, the focus remains on collecting and aggregating data to improve the model continuously.
I've worked with clients who want AI systems to handle edge cases better, and Tesla's method highlights the value of large-scale data collection and rapid iteration.
Regulation is another crucial piece. Autonomous vehicles must adhere to strict safety standards, and the AI systems require rigorous validation to ensure reliability.
That's where business and AI theory meet head-on. Tesla has to not only innovate rapidly, but also manage public trust, legal liability, and safety accountability, showing that AI deployment isn't just about the tech, but also governance.
From a theoretical lens, Tesla's effort exemplifies how AI intersects with real-world constraints. You can have the best machine learning models, but they must operate safely in unpredictable environments.
Speaking of real-world impact, Tesla has pushed the entire automotive industry to rethink their approach. Legacy manufacturers now accelerate AI investments, trying to catch up with Tesla's edge in data and software.
It's a clear demonstration that data about the environment and smart use of it is a strategic asset in AI-driven mobility.
Let me share a quick story. I recently consulted for a logistics company exploring autonomous delivery vehicles. They studied Tesla's data strategy closely because the success relies not only on the AI, but on how you gather, label, and utilize data from actual operation.
That's a valuable insight. Data is often called the fuel for AI, but Tesla's example shows that it's also the feedback loop and the system architecture that make AI applications truly viable.
And beyond mobility, Tesla teaches businesses continuously collecting real-world data, updating models, and delivering improvements through software can create a powerful competitive advantage.
To summarize, Tesla leverages massive amounts of driving data, advanced neural networks, and a software-centric model to produce increasingly autonomous vehicles.
And in doing so, they redefine industry standards, accelerate innovation, and showcase how AI transforms products into evolving platforms.
So, what's our key takeaway for today?
I'd say this. When it comes to AI adoption, success depends on more than just good models. It's about building systems that continuously learn from real-world data and deliver value iteratively.
For me, Tesla exemplifies how the intersection of AI theory, data strategy, and practical engineering can drive groundbreaking innovation, especially in complex real-world domains like autonomous driving.
Next time, we're changing gears to look at another giant in AI, Google, and how they use data to power their ecosystem.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your comments or questions. They might even be featured in a future episode.
Until tomorrow, stay curious, stay data-driven.